Hi everyone, so today I'll be discussing the problem number 19 from LeetCode. It's remove nth node from the end of list. So what's said in the question is that we have to remove the nth node of a linked list starting from the end. So considering this example where n equals to 2, we have to remove the second node starting from the end. So this is the first, this is the second. We remove this 4 and connect 3 and 5, so the linked list is intact, and remove and return the head of the linked list. So one way of doing this is using slow and fast pointers. Okay, so what we need to keep in mind is that we should solve this problem using constant space and linear time complexity, and we should also try to loop this whole linked list only once, not twice or thrice. So considering that, what we can use is two pointers, slow and fast. So let me write that list node slow equals to head and fast also equals to head, because both of the pointers will initially be pointing to head. So the intuition behind this problem is that suppose my let me open my editor. Yeah, so suppose initially both of them are at head. Now if I move fast to the nth node, not nth, if I move fast n steps forward, so if n equals to 2, it moves 2 steps forward, that is 1, this is 2. So fast then points to 3. So this is where fast points. So after this configuration is reached and slow points to head and fast to the n plus 1th node here, now what we will do is loop till the end until fast reaches the end, and we will move both the slow and fast pointers one at a time. So fast moves here, slow moves one step as well, fast moves one step, slow again moves one step. So after that, since there's nothing to go, there's nowhere to go, we'll end the loop, and this is the final configuration. So in the end, slow comes at 3 and fast comes at 5. So now if we observe it, we can see that, okay, suppose position of fast is at x, let position of fast equals to x. So as we can see that slow always lags behind fast by n steps, because we have moved n steps forward already in the start. So then position of slow equals to x minus n. So if fast is at the nth node, that is at the end of the list, then we can say that slow is at end of the list minus n, that is, we can see this statement, nth node from the end of the list, then slow is at the nth node from the end of the list. But not exactly, slow isn't at the end node but the node previously behind that. And the reason is because if we want to remove this node, this 4, we need to be behind this node just previously. So from 3, what we can do is we can write slow dot next equals to slow dot next dot next. If we write this, we are removing this 4th node. We aren't exactly deleting it from memory, but we are removing it from the list. So 3's next was pointing 4. Then what we are doing is slow dot next equals to slow dot next dot next. That means slow's next will, 3's next will now point to 4's next, that is 5. So this is the configuration that we reach, and then we can simply return head. So in this way we can achieve this, complete the solution. So let me start coding. First of all, I equals to 0, well, fast not equals to null. We will move fast in steps forward. Fast equals to fast dot next I plus plus. So once this is done, we need to check if fast equals to null, then we cannot do the next loop. So if fast equals null, return head dot next. This is done. Okay, so now we will move both the pointers one at a time. So until fast is at the end, until fast dot next not equals to null, we move slow equals to slow dot next and fast equals to fast dot next. After this we can simply add these steps. So after this is done, fast dot next not equals to null. So when we are at 5, we can see that like after 5 we can't move forward. So this is where we end. Actually we come to 4, then we move like do fast equals to fast dot next, and it becomes fast becomes 5, and after that we end the loop. So slow comes at 3 and fast comes at 5. So after that from 3 we connect to 5 and delete this 4, and after that we return the original head that was pointing to 1. So this is the basic problem. It's a medium level problem, but if we see it, it's a very simple problem. So let me submit it. As you can see, so and we have traversed the whole linked list only once. We move from 0 to n, then n to the end of the list. This is the first portion and this is the second portion. So overall the time complexity is perfectly O of n. So if you have any doubts, please comment below, and that's it. See you in the next video.